So we're going to do the chapter 2 probability review. And then at the end, what I want to do is I want you all to go back and review any questions that you had difficulty with, and then you can do your final assignment for this project. Okay. Now, we are actually focusing on lesson 1 to lesson 4 of chapter 2. So this problem says the following data were collected in a bike shop, and all that information is actually in our graph. So what we're going to do is we're going to interpret information from the graph and come out with some sort of probability. All right, now calculate the following probabilities as a reduced fraction as a percent. Okay, now let's look at this first one. It says the customer buys a bike, find the probability of buying a Ranger. So we need to find the probability of a Ranger, okay? And how do we do that? We're actually going to have to take a look at the chart that we have here. So you'll notice that for a Ranger, there is a total of 3 spots, 3 Rangers being sold. And then for the outdoor, we got a 5, and so on. And we just fill out the rest of our bar graph to figure out how much we have in total. So now to figure out how much we have in total, all we have to do is total all these numbers. And we've got 3 plus 5 plus 0 plus 2 plus 10 is equal to a final answer of 20. So now if I want to go back to what we were looking at before, all that stuff about the Rangers, we'll have the probability of the Ranger equaling a fraction, right? And in order to do that, we have to know the number of Rangers that we have, which in this case is equal to 3. And then we are dividing by the total number of Rangers, which we found, the total number of bikes sold, which is 20. So once I've got that, we have to change it into a decimal. So 3 divided by 20 is 0.15. And then our final answer is going to be 15%. This next problem is asking us to recalculate the experiment from part A. So we're still going to calculate the probability of a Ranger. But this time we have to figure out what happens when the store discontinues the starburst. So imagine we go onto this chart and we essentially just cross out the starburst, right? In this case, the new total is going to be, instead of 18, instead of 20, it's going to be 18. So now when we calculate the probability of a Ranger, it's now 3 over 18. Which gives us, you divide the top and bottom by 3, and you end up with something over 6, 1 over 6, which gives us a decimal of 0.17, which is 17%. And now let's move on to our new concept of the day. Example 2. Ferd can ride a donkey or walk to work, right? Further, he has a pair of jeans and a pair of yoga pants, okay? And overalls, okay? Lastly, Ferd can either wear a shirt or go bare-chested. Let's go and draw a tree diagram for this situation. Now, here's how we're going to do this. So I'm just going to zoom in on here. I want you guys to just take your time, do not rush into this, okay? I'm actually zooming in so you can see everything that I'm about to write, okay? So we got to think about Ferd and his options. Now, remember, when he starts the day, he can either walk to work or ride a donkey. So his first choice in the day is to walk or take the donkey. Simple thing. Now, the second thing that he has is he has a choice between a pair of jeans or a pair of yoga pants or a pair of overalls. So imagine if he first decided he's going to go for a walk. But now his second choice, he's got three possibilities, and they are jeans, yoga pants, and overalls. So he decides to walk, and then his secondary choice creates another set of leaves on our tree, which are jeans, yogas, and overalls. So now imagine instead of walking, I chose the donkey. I still have those three possibilities again, where after I've chosen the donkey, I can go wear jeans, wear yoga pants, or wear overalls. All right, so now, lastly, he can either wear a shirt or go bare-chested for the day. All right, now, for bare-chested or shirts, we'll just write bare and shirts. So imagine I chose the donkey, right? And then I decide to wear overalls, but then I decided to either go bare-chested or wear a shirt. So now, off the overalls, I end up with two possibilities, bare or shirt. Now, what is cool about this is if I wanted to, I could go down the donkey, go across, and then choose yoga pants, but I still have to choose whether I'm wearing bare or shirt for the day. So we have this happening for the lower half of the tree, which is right here. We literally have two choices for the yoga pants, which would be shirt or bare. And then we also have two choices for the jeans as well. And we'll follow that same pattern for the top half of tree. And following the same rules as before, we have this tree. Overalls goes to bare shirt, and then yoga pants go to bare shirt as well, and jeans also goes to bare and shirt as well. So now let's just take a moment and zoom out a little bit and arrange this so that we can see the entire question. All right, so now on this problem, basically we have just shown the entire tree diagram for this, okay? Now we are going to use this tree diagram to help us figure out certain questions, right? So for example, if I'm looking here, all right, the top half of this information here is for our walk. The bottom half of this tree is for donkey. Starting out with the donkey, okay? Now, if I wanted to figure out the theoretical probability for which the second question of this problem is asking us to do, one of the things that we need to know is how many possibilities there are. And you can actually do that by just reading and counting the number of endpoints on the leaves of the tree that we have here. the end point of all our decision choices, okay? And you end up with something like this. For the top half of our tree, there's 6 possibilities. And then if we continue on, 7, 8, 9, 10, 11, 12. So there's 10 possible ways that I could have chosen all of my things for the day. So now let's go and try to answer this question here. So imagine that I want to find the theoretical probability that Ferd rides his donkey. So rides his donkey. So where would I be walking the donkey? So the donkey would be all of the last half stuff. So I'm going to write that in green. So all of these ones here are donkey riding, right? All of those are donkey rides, okay? So there's 6 possibilities, right? But if you think about it, with our donkey rides, there's 6 possibilities that we end with. But if we go back in time, it asks us something simple. How do I know if I'm looking at that? So all of these 6 possibilities, green dots here, represents when I have my donkey ride, right? But he also wears a shirt. So in order for us to wear a shirt, I'm going to cross off anything that's not a shirt. So this top one, number 7, is gone. This one here, this one here is also gone. This one here is also gone. And then 1, 2, 3. And then this one is also gone. So now that tells us that the possibility for a donkey ride and wears a shirt is going to be 3 out of a total of 12 possibilities. Okay? Now, what's the possibility of Ferd walking to work? Well, just like we said up here on our chart, the possibility of Ferd walking to work is given by, well, P of walking is just 6 possibilities because the top half of our leaves is walking, right? But the total number of possibilities is 12. So you'll notice that we've got all this information. It's nice, right? But we haven't reduced it. Take a look at 3 and 12. Divide 3 and 12 both by 3, and you get a final answer of 1/4 for our probability. And for walking, divide both the top and bottom of 12 and 6 by 6, and that gives us our final answer of 1/2. All right, so now let's go and talk about the final one. We want to figure out what would happen if Ferd rides his donkey to work and does not wear yoga pants. And does not wear yoga pants. So the first thing that we have to do is identify the spot where he rides his donkey. So the lower half, all of this part here is what we're looking at for our problem, right? Now, all we have to do is find where our yoga pants is and not choose anything that's attached to it. So I'm going to check those off. So this one here and this one are attached to jeans, and these 2 here, 11 and 12, are attached to overalls. So I got to check those off, which means the probability of rides his donkey and no yoga pants, this Y with the bar over top means no yoga, equals, well, 4/12. And then we take 4/12 and we divide both of them by 4. And we end up with 1/3 for our final answer. And we're done. So this video is going just a little too long. I'm only going to do one more example from the worksheet. The rest will be posted online as a PDF. If you have any questions, make sure you send them to me. If I find out that all of want me to go and put this information online in a video, let me know and I'll go and do it for questions 4 and 5. All right, so now let's move on to our next topic. All right, so the command on the calculator, rand_int 1, 8, 60 on a graphic calculator generates 60 random numbers between 1 and 8. So now you got to ask yourself, how many numbers between 1 and 4 would you expect to happen? All right, so let's say I wanted to calculate 1, 2, 3, and 4. I needed to have the possibility of 4. The possibility of 4 is, if you think about it, 1, 2, 3, and 4. That's 4 possibilities, right? 4 events divided by 8, which gives us 1/2, which is 0.5, which is also known as 50%. Now, imagine I asked you for that, right? The next thing that I could ask you is, how many would I expect, right? So I would take 50% of 60. Remember, 60 is the total number. So that means 50% is 0.5 times 60, which is equal to 30 that are between are 1, 2, 3, or 4. So now let's go and do this next one here. How many ways could I get 3s as the result? So if I was looking to get 3s as the result, I would start by doing this. Find the probability of 3. So finding the probability of 3, it's 1 out of 8 possibilities, which gives us 0.125 on our calculator, which gives us 12.5%. Now that I have 12.5%, right, I want to take 12.5%, or I could put 1/8 here. And then what I'm going to do is I'm going to times it by 60. And that gives us 0.125 times 60, which gives us 7.5. And so you'd say, so we can expect seven or 8, because 7.5 is between 7 or 8, 3s on average. And we're done. Okay, I lied. I think we can do question number 4. I thought there was 2 extra questions here. But here's our spinner, right? Our spinner is pretty accurate, right? But if you look at this, right, a taxi is the smallest thing in this entire wedge here, right? So let's go and say that a taxi is equal to X likelihood, right? And then what we're going to do is we're going to assume that the cycle and the walk are twice as likely as a taxi. So here's my cycle is 2x, and my walk is also 2x. Okay, so that's a total of 5x spots there, isn't it? So let's go and see what it says here. It says a car is 3 times as likely as a taxi. So here is a car. So a car is 3 times as likely as a taxi. So we'd say that car is 3x. And then a bus is twice as likely as a walk. So a bus A walk is X, so twice, a walk is 2X, so a bus would end up being 4X. Now, if I totaled this, 7 plus 5 is 12 X's. So this represents the sectors of the circle. Now we can use that to our advantage because we know that for every circle has 360 degrees, right? And now it says, find the measure of the angle for a sector, right? For the bus sector. How the heck are we going to do that? The first thing that we have to do is we have to realize that 12x is going to equal 360 because we want to say that the taxi is the smallest, but still all of the different wedges totaled is equal to 360. So now what we're going to do is we're going to divide both sides by 12, and you're going to end up with x is equal to 30 degrees. So each wedge is 30 degrees. So now let's say that I want to figure out what my bus is. My bus wedge is, so here's my bus sector, also known as a wedge, is equal to, well, 4x, right? But x is 30, isn't it? 4 times 30, which means that we have 120 degrees for the bus sector. And we're done. And we're done. Okay, now let's take a look at the next possibility here, the next problem. It says, find the theoretical probability as a reduced fraction, a decimal as a percent of landing on the bus sector. Okay, so let's say I want to calculate the probability of the bus. The probability of the bus is going to be, literally, think about it. Here is the bus sector right here, right? And it represents a wedge of the entire thing, right? And we know that the wedge is out of 360. So our probability is literally going to be 120 over 360 because we had 120 for the bus sector. Now, when you reduce that, you can divide it by 4, divide it by 10. I'm going to divide it by 10. So we got 12 over 36. And then I guess 36 and 12 can both be divided by 6, which means our final answer is going to be 1/3, which is 0.33 when we calculate it on the calculator, which is 33%. And we're done. Now, if I wanted to find out this next bit of not landing on the bus sector, you can think of it this way. The probability of not bus is literally going to be, well, you see how we had 1/3, right? If I wanted to find out how much was left over, I would say, well, the probability of the bus is, well, if it's 1/3 here, then the other possibilities are 2/3, which is going to be 0.67, which is equal to 67%. And now, for the final part, final section of the work. So now, suppose I had, imagine I got like an online spinner, right? So we do have an online spinner that I gave you. You can use it. And you go and run your 10 trials, right? You run your 10 trials and you find the possibility of getting the bus is basically 3 over 10, which is 30%. For 100 trials, it ends up being 31 out of 100, which is 31%. And then when I have 1,000 trials, we have 330 over 1,000, which is approximately 33%. So if we had used the spinner online, that's what would happen. And what that tells us is as we increase the number of trials, the probability, the experimental probability matches the theoretical probability better. Now, let's go and answer this final question here. Suppose walk is not an option, okay? Find the theoretical probability of the bus sector in this case. So imagine that buses are not the option, all right? How does this work? So if buses aren't an option, if that's not an option, I'll just tell you right now, and then you can try to figure it out. So the probability of a new bus is literally going to be 4/10. How did I get that? Send me a message. Try to give me a reason as to why it would work. The key idea is if we hit the spinner on the walk sector, you just have to spin it again. What is the theoretical probability and how does that work? So if the probability ends up being 4/10, how did we get that? The big hint is you have to imagine that you take walk off the table. So you have to go back and you look at what a walk is. A walk is worth 60, right? A walk is worth 60. So imagine it's very similar to what we did when we chopped off one of the bike sales, one of the bikes that were being sold at that company, and we had to do the calculation again. How did I get 4/10? All right, work through it. Now your review, there's two parts to it. If you feel comfortable after you're doing the first one, go do your quiz. If you feel comfortable, if you're not feeling too comfortable, go and do the practice test. Okay? Good luck, guys.